Hello everyone, reporting today for First Updates Now, I'm Abbas, and with me here, I have Team 14343 Escape Velocity from Bellevue, Washington. Their second-year FTC team who's just been absolutely killing it this POWERPLAY season. They were the Final Saline's first pick and won the Inspire Award at their interleague competition about a month ago, and are now gearing up for Washington State's. There's a lot more to this robot than meets the eye, and I'm really excited to dive into this and more coming up on First Updates Now.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. Check out our all-new FTC content coming to Fun's YouTube in February, including new hosts from the FTC community. We'll have resource guides, top 10 moments, behind the bots interviews, and walkthroughs to help your FTC team improve at youtube.com/firstupdatesnow.
Alright guys, why don't we get started with your drivetrain? I think a lot of teams this season have like a traditional four-wheel Mecanum drivetrain, but you guys are anything but that. So walk me through it and the design decisions you guys made and how those turned out.
Yeah, so we have a 5-wheel pentagonal drivetrain, which is inspired by Kiwi Drive and X Drive, because those are also like, they have the motors just in the middle sticking out. We chose this drive base for this year because we needed a way to get between the poles easily, and because the traditional Mecanum drive base is really chunky and like in the shape of a square, which prevents it from going through the poles easier.
So the square's diagonal is way larger than the side that we wanted. Than the size that we would want to traverse between poles. So this drive also helps with that by making a more circular shape. This also improves over Kiwi and X drives as it's more consistent in its driving speed and it has higher power.
Yeah, and so let's talk about the software a little bit behind this. So with controlling 5 motors, are there any challenges you guys have faced, and like how difficult was it to program that?
So getting the actual motors to move, and the drive base to move correctly, was difficult because
Quite a lot of math because you have to make sure all of the wheels are going the right amount of power to move in the right way, especially when it comes to turns. You have to figure out how much power each wheel needs to turn the right direction.
Mm-hmm. And so looking back, is this something you guys would want to do in a future season, if that space constraint was there, or have you guys had your fun with this and you kind of want to move on to a more traditional drivetrain in the future?
I think this is what we want to do, especially because it allowed us to code this movement library that works for any number of wheels in a holonomic drive. So with that, we could maybe even add 6 wheels, or just stick with this 5-wheel drive. And because it really just has its advantages when we want to traverse through a field in many different directions and dodge obstacles.
Yeah, that makes complete sense. So let's dive into your intake a little bit. I was very surprised by how fast it is and all of the different degrees of freedom you have on it. So from my understanding, you guys have made some changes to it to prepare for Washington State's. So why don't you give us a little preview about that, talk to us about it, and what makes it so fast?
Alright, so our first, what we had originally was this vertical slide with this intake on it that would go to the top of the cone. Recently, after Interleak, we added this, which is a horizontal slide on the back of the robot that can extend out, and it has a claw at the end, which could pick up cones. And we have a virtual 4-bar, which could lift this claw up while keeping it parallel with the ground.
Yeah, and so preparing for the Washington State Championship, it's definitely a very, very tough region to advance to the worlds from. And so how much faster has your guys' cycles become, or your overall match score? What changes have you guys seen since implementing this dual intake and outtake design?
Well, so this is a newer technology that we've been working on, and we've just started implementing it. But I think this would allow us to get a 1+5 autonomous at least.
At least, yeah.
Which is
a
lot more than what we were able to do in League 1, League 2, and Intro League.
So even though these motions seem very long when you're grabbing the cone, coming back, and then grabbing the cone with this and then scoring it, it's really short because while we while we're scoring the cone onto the pole, this slide can already be going out and grabbing another cone to score. So
Yeah.
that's why we think it's fast and could help us in the States.
Yeah, and then so like another thing with this is like with so many different degrees of freedom to control. I know you guys said you have your horizontal extension and your virtual 4-bar and your claw and the vertical lift and all of these things. Do you guys use a lot of like automations throughout your teleop and autonomous programs to like speed these up, or like walk us through that and how you guys implemented those?
Yeah. So we have a lot of presets that can like basically where we just hit one button and it does a lot of the actions for us rather than manually doing each of these actions. So for example, one of these presets would be lifting this up and bring this back around while this is coming in, and that just makes it a lot simpler to grab a cone that was from here, and then it's gonna make it a lot easier to score.
Yeah, and I know it might be a little tough to like show with the cone because like you guys aren't like really on the field right now. So without the cone, can we just see like one of your transfer automations or something, and like maybe how fast your lift goes in and out with the horizontal extension? Talking a little bit more about your deposit, or like the part of the claw that picks up from the inside of the cone. Was that a design you guys have had through the whole season, and how has it progressed?
Yeah, so at the start of the season, we were like trying to brainstorm and take ideas, and we didn't want to grab her because we use it here, but it has a lot of issues when it comes to like gripping the cone, and it's a little unreliable, and it can easily drop the cone. So we came up with this cam system, which uses a cam. Wait, oh my god. So this system uses a cam that rotates and pushes these two sides outward. So what we do is that we keep it closed, we go into the cone, then we open it, and we lift the cone up, which is really fast and reliable, and it's like never failed us in a competition.
Yeah, and have you guys had like the same cam system throughout the entire season, or has it like developed and have you made some changes to it?
It's mostly stayed the same throughout the entire season, and
At the start, I don't know if it was like 3, but we found that like way too complex to fit on like such a small intake. On the gap of the cone is also pretty small, so we decided on 2, and that made it a lot simpler. And I don't think it changed the reliability at all.
And yeah, and how are you guys powering this cam mechanism?
we just have one servo that's powering it. And yeah, as you can see in this little demo that we made, this is how it works.
Yeah, no, that's definitely very, yeah, I see like it expanding on the sides, and looks like you guys have like the rubber bands to maintain the contracting features. And so, looking forward at the Washington State Championship, it's going to be extremely competitive, as we've mentioned before. And so what are some of your guys' plans to really make sure you can score all of the points possible and maximize your chances of being a captain and making it to the World Championship?
Yeah.
One thing we're aiming for with this robot design is circuiting, and because we're really fast on the field, that allows us to get more cones on more rods, and that is really useful for circuiting. In addition, we also try to improve our auton, like we said with the 1+5. That increases our score a lot, because we noticed that with a lot of other robots, they also had extremely good autons, and we want to like compete with those. And so this really helps with it, this back claw, as well as like the automation.
So most robots in the game generally have very fast cycle times, but we weren't trying to compete with that because that's really hard to like get past. So what we always just aim for cone vomiting, which is like dropping cones on different poles so that we get more ownership points and circuit points rather than aiming for cycle.
Sure. And so, like, do you guys plan to use your horizontal extension in teleop as well, or is it just reserved for autonomous to get those really high, like 1+5 scores?
Yeah, it still does help us playoff because, first of all, if we decide to cycle, we can still use it, going from either the cone or from substation to the higher poles.
So,
And
yeah,
we can
it's a
still
backup.
also use it during circuiting because it makes it easier because we can stay in one and like get up in that area and then move on to other areas.
Sure. All right, Escape Velocity. I think this has really been a great overview of your robot and a deep dive into things like your cam mechanism for your intake and 5-wheel, 5-motor drivetrain. I'm sure I won't be saying that many more times this season. So thank you very much for this interview. There's a lot to learn from you guys, and I'm really excited to see how you perform at the Washington State Championship. Reporting for First Updates Now, I'm Abbas.
Thank you.
Thank you.
Thank you.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. Check out our all-new FTC content coming to Fun's YouTube in February, including new hosts from the FTC community. We'll have resource guides, top 10 moments, behind the bots interviews, and walkthroughs to help your FTC team improve at youtube.com/firstupdatesnow. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.